Hello and welcome back to Elementary Statistics. So we are now getting into section 1.3. So let's jump right in. So this section is going to be looking at collecting sample data. So now the first part of this, the key concept, the method used to collect sample data influences the quality of the statistical analysis. Of particular importance is the simple random sample. If sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. So every time you come to class, you can think of statistical torturing. Isn't that great? All right. So what is a simple random sample? So I'm going to pop open the whole thing. So a simple random sample, a sample of n subjects, is selected in such a way that every possible sample of the same size n has the same chance of being chosen. Okay, so what that means is, let's say we have our class of 20 students. And I said, okay, I want to separate them into groups of 4. So I'll have this group over here, I'll have this group over here, another group, another group, another group. And so I get everybody in their groups of 4. And so if I were to pick any of those groups randomly, they all have an equal chance of being chosen. Same chance of being chosen. Okay, so that makes sense, right? All right, so now let's do it again. So now I'm going to do different groups of 4 and say, okay, I got this group, this group, this group, this group, and then I do the same thing. Does every group have the same chance of being chosen? Yes. So that's kind of the idea. So they're looking at a group mentality with randomness in there. Now, so that can be a little bit confusing, and so why it's called simple, I don't know. But the next part of it looks at a more common case. So we got a simple random sample is often called just a random sample, but strictly speaking, a random sample has the weaker requirement that all members of the population have the same chance of being selected. So now they're looking more at an individual basis for that. So if I threw everybody's name into a hat and I scrambled it around, does everybody have an equal chance of being picked? Sure. So that's kind of the idea behind a random sample. It's more dealing with individuals than with groups. So the big thing is that they're random. So there's only, like I said, a couple of different ways to do a true random sample. So, drawing names out of a hat or using a computer program to do a random number generator type of thing, that would give you a random sample as well. So let's take a look at some other ways that we can get samples. So systematic sampling, we would select some starting point and then select every kth element in the population. So, if we're picking every third car, that would be systematic. In elementary school, it's like, okay, let's form teams for kickball. Okay, number 1, number 2, number 1, number 2, number 1, number 2. So that's a systematic sampling method. Is it random though? Is it random that is happening? The answer is no. Because truly random would mean we put all those kids' names in a hat and then we pick names to get the 2 teams. So it's not, even though it's, it seems logical and everything, it's not random. So we got to be careful. Convenience sampling. Use data that are very easy to get. So okay, if I wanted to do a sampling of, for a survey that I'm conducting about the college. So instead of looking at all the students in the entire college, I just look at my class and say, okay, I'm going to use you as my sample. I'll give you the survey and you fill it out, and that'll give me information about the entire college student body. Is that random? No, it's not random either. So truly random means everybody has a shot at being in that sample. And if I just pick the class in front of me, that's not going to be random. So that doesn't work out as well. But it is a way to get a sample. It doesn't mean it's terrible. It just means there might be some flaws with the process. So let's see what else we got. Stratified sampling. So stratified, if we subdivide the population into at least 2 different subgroups or strata, so that the subjects within them, within the same subgroup share the same characteristics, then draw from the sample from each subgroup or stratum. All right, this is a very confusing way to describe it. I'm going to show you in your notes in just a second a way that I like to differentiate between this one and the next one because they're very similar. So hold on this for a second and let's read what the next one looks like. So the next one is cluster. Cluster says to divide the population into sections or clusters, then randomly select some of those clusters and choose all of the members from those selected clusters. Okay, so let's take a look at your notes. If we're in our notes, you have this page in your notes, we had stratified and we got cluster. So the way I'm going to show you how to differentiate between these two a little bit easier is let's just draw a couple of embryos. So we'll draw a circle, we'll draw another circle, make it a little bit perfect. Okay, and now we're going to chop it up into actual embryos. So we're going to have some cells. So we got one here, boom, boom. And let's do it over here as well. Now the way I like to differentiate between these two is that stratified is really looking at sum of all. I'll put it in quotes. Sum of all. And this one is all of sum. Now why is it like that? Well, let's read it one more time. So subdivide it into at least two different subgroups. We divided it into a bunch. Then draw a sample from each subgroup. So each of these are considered subgroups. So I'm going to take 3 elements from each one. So in this sense, out of the entire population, all of these subgroups have some representatives that contribute to my sample. So sum of all of the subgroups. So you're taking a little bit out of each and every one of them, so all of the subgroups are represented, excuse me. Just the opposite for cluster. Cluster wants you to divide it up into groups, so we did, and then randomly select some of those clusters and choose all of the members in those clusters. So I'm going to say, okay, I want this cluster, and I'm going to take everybody out of it. I'm going to take this one, I'm going to take everybody out of this one, and I guess I'll do this one too. So now my sample is comprised of all the people in here, all the people in here, all the people in here, out of the entire population. So again, it's another way to try to do a sampling. Might not be random. Really, this isn't random, because if it was random, I might have picked this subgroup right next to this one, so, or the one in the middle or something like that. But it is a way to get a sample. So that's I think the best way to differentiate between these two. So sum of all of sum. And so that way, like I said, it helps just keep it separate. The biggest thing is that there's 2 layers to the sampling process. The first layer was subdivide it into smaller groups. And then the second part is you're taking a little bit of all of them, or you're taking all of some of them. So, okay, so hopefully that helps. So let's jump back to the notes. Now the last type of sampling is considered multi-stage sampling. So it says collect data by using some combination of the basic sampling methods. In a multi-stage sampling design, pollsters select a sample in different stages, and each stage might use different methods of sampling. So basically it's just a mix mash of all of them, or some of them. So if I said I wanted to do a stratified random sample, so I'm going to do stratified, so I'm going to subdivide it initially, but then to get those smaller samples from each of those subgroups, I'm going to put all the names in a hat and draw them out. So again, it's just some sort of combination. So in looking at our notes, looks like we have some examples from the textbook, so I'm going to pop over there. All right, and we want to go to page 32. start. So looking at number 9, identify which of the sampling methods is used, random, systematic, convenience, stratified, or cluster. So I'm not going to try to pronounce that. Bird population densities were studied by using the line transect method with aircraft observers flying along the shoreline of Lake Huron and collecting sample data at intervals of every 20 kilometers based on data from blah, blah, blah. Okay, so which one do you think this is going to be? So we have random, systematic, stratified, what? Well, it's regular intervals of 20 kilometers. So they go 20 kilometers, stop, let's grab some samples. All right, let's keep going, grab some samples. That's pretty systematic in how they're getting those samples. So I would argue that that is a systematic method. So hopefully that makes sense. Let's try the next one, which is number 11. UFO poll. In a Kelton research poll, 1,114 Americans 18 years of age or older were called after their telephone numbers were randomly generated by a computer, and 36% of the respondents said that they believe in the existence of UFOs. Now, this one is deceiving because it looks like there's 2 layers to the process. So we got the first layer, and then we got this 36%, blah, blah, blah. It's deceiving because the 36% really is talking about the results, not the sampling method. That has nothing to do with the sampling method. How were those people picked? That's what they're asking. That's what you have to answer. So in this case, they were randomly generated by a computer. It says it right in there. And we said before that that is one of our methods for doing a true random sample. So in this case, it would be random. All right. Moving on down to 15. This is another controversial one. The author collected sample data by randomly selecting 5 books from each of the categories of science, fiction, and history. The number of pages in the book were then identified. So again, we're trying to look at how the sample was collected. So in this case, it looks like there's 2 layers to the process. They're eventually getting numbers of pages. So how did they get those numbers of pages? So just ignore that. So those number of pages, there's 2 layers to it. So I would automatically reduce your choices down to either stratified or cluster. It's got to be one of those 2. There's 2 layers. So are they doing all of some or some of all? Now, if you look at the textbook answer actually says stratified. So they're saying some of all. And I would almost argue against that because, okay, they're taking 5 books from each of those categories. That's only some groups, some books. So those books, each book is like a subgroup of all of the subgroups in those different genres. So if they're only taking 5 out of each one, but then they're looking at all of the pages, the number of pages in each of those 5 books is what's being used as your sample data. So I say that leans more towards all of some. All of the page numbers were recorded in some of the textbooks from those genres, out of all the population of genres. So I might be reading it wrong, which I'm big enough to admit, but that's the way I would interpret it. In general, I will try to make sure that the questions aren't too ambiguous, so there's not too much choice of which one it could possibly be. But in this case, I would lean more towards cluster. The textbook, the author leans more towards stratified. So if you have a reason to believe it is stratified and you want to explain it, definitely go for it. So, all right, let's move on to the last one, which is 17. It says testing Lipitor. In a clinical trial of the cholesterol drug Lipitor, subjects were partitioned into groups given a placebo or Lipitor doses of those doses. The subjects were randomly assigned to the different treatment groups. So this one is deceiving. It looks like there's a couple of layers to it, but it really is just one layer. How were those subjects assigned to their groups? And it says it right there. They were just randomly assigned. So there's not really 2 layers to this one at all. There's just the one layer. How were the subjects put into those treatment groups? it was randomly done. All right, I'm going to just do one more just because I want to make sure you see enough of a variety. Let's do 19. Literary Digest poll. In 1936, Literary Digest magazine mailed questionnaires to 10 million people. That's a lot. And obtained 2.2 million responses. The responses indicated that Alf Landon would win the presidential election. He didn't. So what's wrong with this? So, I mean, that seems like a pretty big sample, right? But there's problems with that. Look at the magazine, Literary Digest magazine. So back in the 30s, only those that were rich had magazines. So those 10 million people were probably in some database that they already had, which is pretty convenient for them to get that sample. They didn't look at average Joe, that doesn't have a magazine subscription. They only had those 10 million people that had those magazines. So right there, it's a biased sample. It was convenient. So even though there was a strong set of responses, which was voluntary, so again, there's bias again, chances are there's going to be flaws in it, which there was. So even though it was a big sample, it was a biased sample. So that ruined the survey. That is where we're going to stop for this video, and then we'll pick up the rest of it in the next one. So see you in just a few minutes.